In this bite-sized podcast today, we are decoding ChatGPT and what makes ChatGPT a chat. We're about to really unpack what allows ChatGPT to feel like it's holding a conversation with you. It's pretty mind-blowing when you really look under the hood.
Absolutely. And at its core, that ability, it really hinges on machine learning. Think of it like algorithms learning from just tons and tons of information. They start recognizing patterns, making predictions, all without being explicitly told every single step. And the more data they see, the better they get.
It really makes you think, doesn't it? This whole AI explosion feels so sudden, especially like generative AI creating images and text. But AI, well, it's actually been around for ages, right? Netflix recommendations since 2000, that's a practically ancient history in tech. And things like spotting tumors in medical scans. AI has been quietly working there for years.
That's a really key point. What we're seeing now with ChatGPT, it builds on that long history. And the real powerhouse behind this current wave, it's neural networks and deep learning. The original idea was sort of sparked by trying to mimic, well, how the human brain is structured.
Mimicking the brain. Wow. Sounds futuristic, but the concept's been around, hasn't it?
Yeah.
So what was the tipping point? What made it take off so much recently?
It really came down to two big things happening together.
Mm-hmm.
Just a massive increase in the data available for training and a huge leap forward in computing power. Deep learning models, they just thrive on enormous data sets, and being able to actually process all that information efficiently, that was the game changer.
Okay, right. So we have this super powerful machine learning engine fueled by loads of data and deep learning. But what's the secret sauce that makes ChatGPT actually chat? Because, just spitting out text isn't really the same as a conversation, is it?
You're spot on. The chat part, well, that largely comes from a process called reinforcement learning from human feedback, RLHF for short. And this is a really critical innovation. It sets models like ChatGPT apart from earlier ones that were mostly just predicting the next word.
Reinforcement learning from human feedback. Okay, RLHF sounds involved. Can you break that down a bit?
Sure. So it starts with something called pre-training. The model is just shown a colossal amount of text data. Think books, articles, websites, basically, a huge chunk of the internet. This lets it learn the fundamental structure of language, grammar, facts about the world, how things fit together. Imagine reading almost everything publicly available online. That's the kind of scale we're talking about.
Yeah. Just train it on the whole internet. That's a staggering amount of information. So where does the human feedback actually come in? Are there known issues with just using internet text?
Right, exactly. Because the internet has, well, everything. Good stuff, bad stuff, misinformation, toxic content, you name it. So just learning from that can be problematic. That's where the human feedback stage is crucial. After pre-training, the model generates responses to prompts. Then, actual humans step in. We look at maybe two different answers the model gives and say, okay, this one's better, or this one's more helpful, or this one feels safer. So it's not just reading the internet, it's actively learning from us what makes a good, helpful conversational response. That's the leap.
So it's kind of like a giant thumbs up, thumbs down system for the AI's answers, guided by people.
Pretty much, yeah. That human feedback acts as a reward signal. The model then uses this signal to fine-tune itself, to adjust its internal workings. It learns to connect certain ways of responding with positive feedback, the answers we like, and other ways with negative feedback. And this whole process shapes it to become more conversational, more helpful, basically, guiding it towards what we humans actually prefer.
That's fascinating. So we're sort of teaching the AI conversational manners in a way. Does this fine-tuning, this RLHF, really make that big a difference in performance?
Oh, the impact is actually quite remarkable. There's evidence showing that a smaller language model, once it's fine-tuned with RLHF, it can significantly outperform a much larger model that only had the pre-training. In some tests, these RLHF-tuned models have even hit what people call superhuman performance on certain question-answering tasks compared to models trained just on data or through other supervised methods. It really highlights the power of aligning these things with human expectations.
Wow. Okay, that is surprising. Smaller but better guided beats sheer size sometimes. Now, you mentioned something called KL control during this fine-tuning. Sounded a bit technical. What's that about?
It is a bit technical, but the core idea is really important. KL control, it stands for, Kullback-Leibler. Divergence control is a technique used during that RL fine-tuning stage. Think of it like this. You're training a dog a new trick, rewarding it when it gets close. But you don't want it to completely forget basic commands like sit or stay, right? KL control is like making sure ChatGPT doesn't forget the fundamental language patterns that sit and stay that it learned during pre-training, even while it's learning the new conversational tricks from our feedback. Basically, it stops the model from going completely off the rails just to chase that reward signal. It keeps it grounded. It balances learning new things with remembering the basics.
Okay, I think I get that analogy. So it stops the AI from just like obsessing over the reward and producing nonsense if the reward system isn't perfect.
Exactly. Without something like KL control, the model might find weird loopholes. It might figure out some strange output that technically gets a high reward score, but is actually gibberish or completely useless. Remember that music generation example? If the reward was flawed, maybe rewarding just repeating a note, without KL control, the model might just output CCC over and over. It maximizes the flawed reward, but ignores everything it learned about actual music.
Right, like a student just memorizing answers for a test but not understanding anything. So how did KL control help in that music case?
Well, by using KL control, the model was encouraged to stay relatively close to the patterns it learned from all that real music data during pre-training. So while it was trying to get a better score based on the reward signal, maybe related to music theory rules or something, it couldn't just abandon what it knew about musical structure. And that led to the toothpaste jingle example. Maybe not a masterpiece, but definitely more musical and coherent than just CCC. It stayed recognizably music-like while optimizing.
A toothpaste jingle. Okay, well, progress. And you mentioned this approach, this KL-controlled RL fine-tuning, has legs beyond chatbots and jingles.
Absolutely. The same fundamental ideas are being used successfully in other fields too, like drug discovery. Researchers are using it to help generate potential new drug molecules. The goal is molecules that are not just theoretically effective, getting a high reward, but also, actually likely to be synthesizable in a lab, staying close to the patterns of known valid molecules, the KL control part.
Huh, that's a really cool connection. So this whole RLHF process with the KL control acting as a kind of safety rail has really become the main way to make these powerful language models safer and more aligned with what we humans actually want them to do.
Exactly that. Right now, it's the primary tool we have for steering these large models away from generating harmful, toxic, or just unhelpful outputs. By baking human preferences right into the learning process, we can guide the AI towards being genuinely useful and, frankly, less problematic.
So, when ChatGPT politely refuses to tell me how to build something dangerous, that's largely RLHF at work, thanking the human feedback.
In large part, yes. The way it typically works these days is humans compare pairs of responses. So the model generates response A and response B to the same prompt. Humans look at both and say, I prefer B, based on criteria like helpfulness, honesty, harmlessness. All this comparison data, millions of these preferences, is then used to train a separate model called a reward model. And interestingly, behind the scenes, there's often a mathematical model, borrowed from behavioral economics actually, called the Bradley-Terry-Luce or BTL model. It tries to predict the probability that a human would prefer one response over another based on some underlying reward score for each response.
A reward model that learns our preferences and then uses that to train the main AI.
Precisely. This reward model gets good at predicting human preferences. Then, it can automatically score outputs from the main language model during the fine-tuning phase. That score guides the reinforcement learning, usually with KL control, like we talked about, keeping it on track.
It's like this whole ecosystem of feedback and checks and balances. Okay. Now, you also mentioned this approach, powerful as it is, hits some snags, especially because, well, people don't all want the same thing, right?
That's a really, really critical point and a major challenge. The standard approach, especially with models like BTL, often implicitly assumes there's one single universal best way to respond, or one set of preferences everyone shares. But as you said, that's just not true. What one person finds helpful, say, a really concise answer, another might find too brief and unhelpful. They might want more detail.
Yeah, definitely. I might want the quick summary, but someone else needs the full step-by-step explanation. How does a single reward system based on averaging preferences handle that kind of diversity?
Well, that's where the limitations really bite. If you try to average out feedback from people with vastly different needs or values into one single reward function, you can end up with outcomes that aren't great for anyone. Think about that college admissions chatbot example. If it's mostly trained on feedback from students who don't need financial aid info, the reward model might learn that downplaying financial aid questions leads to higher average preference scores. So the chatbot might learn to ignore or give unhelpful answers about financial aid, which is terrible for the students who desperately need that information. It caters to the majority or average preference and fails minorities or those with different needs.
Ooh, yeah, that makes total sense. And that sounds like it could lead to some really frustrating, even unfair AI interactions. You had another example with robots.
Right. Imagine a robot learning to navigate. Maybe one group of people providing feedback wants it to go to one corner of a room, and another equally large group wants it to go to the opposite corner. If you train a single reward function trying to satisfy both groups equally, what might happen? The robot learns the compromise, just go to the dead center of the room.
Hmm.
But here's the thing. Nobody actually wanted it to go to the middle. Trying to find that single average preference resulted in a behavior that satisfied literally no one.
So, averaging diverse preferences can lead to just mediocre or unwanted results. What's the path forward then? How do we build AI that can handle this messy reality of different people wanting different things?
It's a really active area of research. One set of ideas falls under pluralistic alignment. The goal here is to explicitly acknowledge that there isn't one right answer, but maybe several clusters of valid preferences. There's also work on distributional alignment, which aims to make the AI's behavior reflect the entire distribution of human preferences, not just the average.
Okay, so instead of forcing one best answer, the AI tries to understand there are different good answers depending on who you are or what you value.
Exactly. And building on that, there's really exciting progress being made in personalizing RLHF. The idea here is to learn a sort of individual user profile based on your specific feedback. The model learns what you tend to prefer. So instead of relying only on general human preferences, it starts tailoring its responses more to you. For instance, in that simulated robotics task where people had different ideas about where items should go, these personalized RLHF methods were much better at learning each person's preference and having the robot behave accordingly, rather than just finding a one-size-fits-none compromise. It's about moving towards AI that can genuinely adapt to the nuances of individual needs and values.
That sounds like a much more useful and, frankly, less frustrating future for AI assistants. Wow. Well, this has been a truly fascinating look behind the curtain at what makes ChatGPT chat. It's really incredible how much complex technology and, well, human input goes into creating what feels like such a simple conversation sometimes.
It really is. It's a field that's moving incredibly fast, constantly evolving.
See you soon with another one of this.